Alright, cool. I'm at home now, and let me see if I can adjust this a little bit. Yeah, so I'm not sure how much I'm going to push on for, but let's get cracking. Where I left off was I actually was struggling with this whole issue of like where the WebGL renderer struct should be owned, and like dealing with interior mutability and references and lifetimes, I guess like typical Rust stuff that I don't know yet really. And I saw this awesome comment from someone on the Rust users forum, which is really, really helpful. Which is this. So Rust's borrow checker unfortunately has no way to express call a method giving it access to some but not all fields. Just anyway, so yeah, so essentially the issue is that, let me open up the actual code. Where was it? Quad, it's going to be in the quad scene stuff between like the renderer and whatever. Yeah, so I'm borrowing self as mutable, but then I want to borrow self dot WebGL renderer as also as mutable. So why is that a problem? Oh, I think the issue is because you can only have one mutable reference at a time. Because like the idea is that mutable really means exclusive. So in this case, I'm trying to borrow self as, like I'm trying to get an exclusive reference to self, and then I'm trying to get an exclusive reference to something that self contains. And both of those, even though I know they're kind of happening like in a non-conflicting way, Rust has no way to know that. Like I could be mutating either of them, like independently or in ways that, I don't know, that I'm not like using threads or anything, but yeah, basically Rust doesn't allow having two mutable references or splitting off mutable references from within like another mutable reference. So so yeah, this isn't going to work. The advice that Cornell, I'm not sure how to pronounce, Cornell said is really awesome. These like 4 different ideas. So we could pass the context to tick, which is what I was doing originally, and I decided that I don't want to do that because I want a generic render function within tick. Like if we go to the DOM handler stuff, DOM handlers. So if we see here, like this is really nice that each scene it just calls its tick with a timestamp, and from the request animation frame loop from the ticker, it doesn't care what it's doing with that number, and I think later on that's going to be relevant because we'll want one renderer to maybe update DOM elements, maybe we want to render out sound, of course the WebGL stuff, and I think rather than like dealing with like matching a type of scene here, I'd rather like the request animation frame loop just just pass this timestamp down and not really care what it's doing and keep this really abstract and clean, and then within the scene let it like handle what it needs to. So for that to work, it means that the scene must own everything, like all the I/O hooks, because it's being called in this DOM handler loop, which has a static lifetime, because it has to be able to talk to JavaScript, and so therefore, like everything from its perspective has to, like, we can't pass any like references down that will last between cycles. Like it can't like store that reference between the cycles. Rather, it has to own it, or the things it owns has to own it. So that's why we're passing a RC with a ref cell inside for interior immutability, and that's what we're giving to scene, so that the scene can own the WebGL renderer. Okay, so we're pretty good on that front. Like I think that architecture is solid. Problem is, so now which approach do we use? So we know we don't want to pass context every tick. Okay, so let's like cross that one off the list. We don't want to do that. Keep using self.context and reborrow each time. I think the idea there would be that instead of calling self.render with the borrow, we would call self.render with and just pass the RC down, and then basically at some point down the chain when we're no longer getting immutable self, we'll pass a context, unwrap it, and do stuff. I'm not sure exactly what that would look like, but I think that's the basic idea. I intuitively don't really like that, because it means that we're going to be doing our unwrapping or our calling into ref cell like at a lower level of abstraction, and that almost definitely will mean that we're going to be calling it more than we need to, because we could unwrap it higher up and then just like pass a reference down. Whereas if we're passing the ref cell down to like all the things with all its tendrils at the end, it's going to be like doing it at each like terminal point like later on, and so I want to avoid that if we can. Okay. Next, refactor self into two smaller objects, one with the context used as read only and one without, used as mutable. I was actually kind of thinking along those lines, which is maybe kind of why I'm like steering towards it. It's a little weird in a way, like it's not how I would have organically thought of splitting the problem, but I don't mind it. I think the win of having things be like clear, not like calling into ref cell more than we need to. It's actually almost like a separation of concerns of like we have the mutable changes we need to make per tick for rendering, and then we have just like blasting through the immutable render stuff. I kind of like it. It'll still happen, like one will happen back to back. Like what I don't want is that we have to like store a cache of like all the mutable data for like all of like later on when we have multiple meshes, like each one storing its per render data, pure render mutable data. But yeah, I think this is kind of like the direction to go in. And this last one of use self with context argument and interior mutability for other fields too. No, and it's I'm really happy that he shared that as like a to kind of teach me how to think about Rust. But no, we want to like avoid the need for calling into these like ref cells unnecessarily. So we're going to do this. We're going to refactor self into two smaller objects. One with the context uses read only, and one without used as mutable. That's our goal. So yeah. Okay, so what we really have is within the scene we have our WebGL renderer. I'm not really thrilled that we have this like quad renderer as like a separate thing. I don't think that that's necessary, and especially now that I'm looking at the code on a bigger screen, I kind of want to like move that out, I think. But okay, let's say data. Let's say game data, actually. Yeah, actually, let's do like this. Let's do like, well, yeah. Okay, so we have game data. And then I would say let's have our render data. Render data. Game data. Yeah, let's split it up like that. And so quad scene owns it. Yeah. If anyone's here. Is anyone watching? I don't think this like tells me if anyone's watching. It's just like if anyone's typing. Whatever. Okay. So I don't because I'm at home. I don't have like two monitors, so I'm not gonna easily know like if someone pops in, even if you say hi. But I'll check every now and then. Alright, cool. So, right, let's get in our example thing. Rust. What? Yeah, basic quad. Alright. So, alright, this is interesting. So I had this like quad data. I don't know if I really want to split it up like that. I mean, I'm also kind of like unnecessarily like optimizing this early. Like, there's no reason why render data and the game data have to really be different. But I like that they are for reasons of like being able to pass. Actually, the truth is, if it's pure data, it doesn't matter. I was thinking like for like functional reactive programming or passing it in separate threads. They really don't need to be separate. So let's, yeah, it's like inside of it, it could contain it. Though, why would it push? If we were doing separate threads, like it wouldn't need to like. Yeah, let's just keep it all together for now. We could like optimize that better later. So okay, so we have quad data. Okay. You know what we could do is let's like maybe put it here and say render data. Getting rid of our quad render at some point, but for now, alright, Oh, interesting. We already had a hint that we wanted to like kind of start moving stuff out. Okay. Where's this right with it's probably one of these. Right. Okay. Yeah, because we're going to want to register our program with it. The truth is, I think really we're talking about like all this stuff. Create bound. Oh, right, okay. Yeah, literally, okay. Alright, the trait bound. What? Continue pub. Quad render data. Oh, right. Yeah, now we're cooking. Right, so now our quad data will create the render data. Okay. Okay. And now I can get rid of all this. So let's get rid of this whole quad render thing. It's totally unnecessary. Quad. I almost say it's just quad, right? Let's call it quad scene for now. Fix all this in a minute. Yeah, I almost want to call it a quad render instead of a quad scene, but it's fine. Okay, so now we have our well, wait, there is no such thing as a quad render anymore. Why is this? I think maybe just getting weird stuff. Vim can't even deal with that. Alright. I think let's just do stuff. Alright, first of all, it's WebGL render equals this. Let's take it like that. big fat error here. Restart Vim. Come on, scream at me. You know what, I think maybe try and cargo built. Yeah, alright. Oh, because it's such a high level up in the thing, it's like even at the module level it's messing up. Alright, maybe that's why. So what we want to do is quad mod, bam. Ah, there we go. Nice. Alright. So what's our first error here? Cannot be applied to try. Okay. Right. So it's borrow. Try borrow mute. Oh, right, but we can't convert from borrow mute error. So I want to yeah, we should be able to just do any toString map. Should go to just whatever. It's just s.to or e.toString because I think it satisfies that trait. Oh no, because it's not map, it's map error. Okay, cool. Alright, so now we're back to good error handling also, which is nice. Alright, this function takes one parameter, but 0 oversupplied. Yeah, that's because we want WebGL renderer. Yeah. Alright. Oh, but we want to keep it as the ref cell. Because we're not going to be messing with like lifetimes and all that here. Although, now that we're keeping it, can we keep it as a reference? No, probably not. No, of course not, because we're going to drop it here, so if we try and keep it as a reference, that won't work. Okay, so let's hold on to this. So we have that. Actually, this also now is expected struct. Oh, right, because you know, it's a better name. Yeah. Okay, good. Alright, so now in our tick, what are we doing? Alright, so self.data.update. I think that's pretty much what we want to do. Let's go look at our data, quad data. Update with immutable self, yeah. Let's. I kind of want to. You know what? We're inside the tick here, so now let's do this. Update game data, and then update render data. Okay, now the whole point here is that, oh, whoa, whoops. Okay, so now in our signature for the, for a renderer, we do not need it to be mutable self, it just needs to be take a reference to self, and but it does need to have a mutable render because it might change programs and stuff. Right? Okay. Alright, so people, that should now be correct. Yeah, and now here, we have self.render. Oh no, let's kind of follow this dude again. Nice. Good. That makes sense. Glad we went that route. Okay. All right, so actually, all these, okay, there's some of this is going to happen here. Oh, shoot. No, it's right, it's right. That's the whole point, is that we don't actually write to any of the GL stuff. It's just pure render data.